Hey guys, welcome back to another video on the channel. So in the last video, we have solved the first 8 integer questions of this particular question paper. Alright, so we have solved all these integer section questions. So the question paper is based on conic sections. So in mathematics, you can see the syllabus. It is ellipse and hyperbola. Alright, so these questions are all based on ellipse and hyperbola. And we have solved the first 8 questions. So in this session, what we are going to do is we are going to solve the next 6 questions, which are multi-correct answer questions. So these questions can have one or more than one correct answer. So let us go ahead and solve these questions. Okay, so I've pasted the first question here. So what you have here is a hyperbola. All right. Yeah. In the question, you can see there is an equation given: x square upon 25 minus y square upon 9 is equals to 1 with foci s and s dash, where s is on positive x-axis. Okay, let me draw a proper tangent. So this is the tangent at P, and a straight line is passing through S and having the same slope as that of P. So now a straight line is passing through S, which has the same slope as that of this particular tangent to the hyperbola, intersects the line S dash P at Q. So when you extend this line S dash P, this tangent intersects this line at Q. Let alpha be the shortest distance of P from the line SQ. Okay, and this is alpha, shortest distance of the point P from SQ, and beta is S dash of P. So S dash of P, S dash P. So this particular length is beta. So this looks like the previous JEE advanced question. All right, then they are asking us to find out the value of alpha and beta. Okay, so this is the equation that we have. Now with S and S dash, where S is on the positive x-axis. So let us make one figure. Okay, so this is your positive x-axis, and you have a hyperbola that looks something like this. So this is your S, which is your focus on the positive x-axis, and this is your S dash, which is your focus on the negative x-axis. Let P be a point on the hyperbola in the first quadrant. So let this be P. A straight line passing through, okay, and also SP S dash is given. So this particular angle is given. So this angle is 60 degrees. The straight line passing through S and having the same slope as that of tangent at P. So now you have to draw a tangent at P. So this is the tangent at P, and now they are telling that you have to draw a straight line passing through S, which is having the same slope as that of tangent at P. So these two green lines will be parallel to each other. Intersects the line S dash P at Q. So this straight line intersects the line S dash P at Q. All right. Now let alpha be the shortest distance of P from the line SQ. So this is alpha. So this distance is alpha, and beta is simply S dash of P. So this distance is beta. Then they're asking us to find out alpha, beta, and area of triangle formed by tangent. Okay, angle between asymptotes of H and locus of foot of the perpendicular. Okay, fine. So they're asking us to find out alpha and beta. Now what can be done is, okay, so now you should not even spend time while to solve this question. You should very quickly solve this question, because this is a previous JEE advanced question. All right, so if this length is alpha, so this length is also alpha, because these two green lines are parallel to each other. So this length is also alpha. Now, and also one more thing, what we can do here is, like, this is a previous JEE question, but I, like, just for the sake of explaining you the concept once again, I'm going to solve this question. All right, let us extend this particular tangent a bit, and let us draw a perpendicular from this focus onto this particular tangent. All right, so this is perpendicular. All right, let us say this is T dash, and since this is S, let us say this perpendicular is T. So this green line is a tangent, and this particular red line is a perpendicular drawn from this focus on this tangent, and this is a perpendicular drawn from this focus on this particular tangent. So we have a tangent, and on that tangent we are drawing perpendiculars from the two focuses, from the two foci. All right, so then there is a very interesting property about these lengths. So you can prove it. If you don't know the proof, let me know in the comment section. I will make a video on it. So ST into S dash T dash is simply your B square. So in this case, your B square is 9. So ST multiplied by S dash T dash is equals to 9. We know ST is alpha multiplied by, we have to find out S dash T dash. So how do we find out S dash T dash? So again, one more thing, one more property I want to introduce. I mean, like, I want to point out here. So this is a point on the hyperbola, and these two, I mean, like, these two are the lines joining that point to the foci of the hyperbola. And when you draw a tangent at that point, this tangent divides this angle, and this tangent bisects this angle. So therefore, also you can prove this property. So if you don't know the proof, let me know in the comment section. I'll prove it in the next video. I'll explain all these concepts in the next video. So these two angles will be 30 degrees. Now you consider triangle P S dash T dash. When you consider that, when you apply sine 30 will be S dash T dash upon S dash P. So this is half is equals to S dash T dash by S dash P is already given. So that is beta. So therefore S dash T dash is equals to beta upon 2. Now put this S dash T dash into this equation. So this is beta by 2. So from that you will get alpha beta is equals to 18. All right, I hope I am clear. So option A is correct. Now area of triangle found by any tangent to H with its asymptotes. Alright, area of triangle found by any tangent to H with its asymptotes. Okay, so they're asking you to find out the area of any triangle. So since they're telling that the area of any triangle will be same, what we can do is we can draw the asymptotes. Okay, and these two will be the asymptotes. Now let us say there is a point here. We will try to find out the area form. We can draw the tangent here. It will be a vertical tangent. So now we have to find this particular area. What are the equations of asymptotes of hyperbola? So if x square upon a square minus y square upon b square is equals to 1, if this is your hyperbola, then your asymptotes will be y is equals to b upon ax and y is equals to minus b upon ax. So these will be your asymptotes. Now in your case, b is equals to 3 and a is equals to 5. So let us try to find out the asymptotes. Y is equals to 3 upon 5x and y is equals to minus 3 by 5x. So the equation of this line is y equals to 3 by 5x, and the equation of this particular asymptote is y equals to minus 3 by 5x. Now this is origin 0 comma 0, and this point is a comma 0, which is your 5 comma 0. Now what will be this point? This point will be 5 comma 3. So therefore we can find out the area of this triangle. So that will be half into base. Base is 5 and height is 3. So since we have two triangles like that, So this will be multiplied by 2. So that therefore the area of that triangle is 15. So therefore the second option is also correct. So you should not draw this vertical tangent and find out the area. They asked about any tangent, so you can find out the area. Like they asked for any generic tangent, but since the answer will be the same, so I just took that special case for the simplicity of my calculation. All right, now the third option, they are asking us to find out the angle between the asymptotes. Let us say this angle is theta. Then if you apply tan theta will be 3 divided by 5. All right, but we need 2 theta. We need the value of 2 theta. So therefore tan 2 theta is equals to 2 tan theta upon 1 minus tan square theta. So that will give you 6 upon 5 multiplied by 25 upon 16. 5 ones, 5 fives. 5 6 30 upon 16. So this will be 15 upon 8. So 2 theta is tan inverse 15 upon 8. So this is wrong. So these two angles are not perpendicular to each other. So you can directly tell that from the slopes also, since they are telling the angle is 90 degrees, and you know that that your slopes are 3 upon 5 and minus 3 upon 5. The product of those two is not minus 1. So therefore the angle between them will not be equals to pi by 2. So therefore this particular option is wrong. Next, the locus of foot of the perpendicular drawn from foci of H upon any tangent is x square plus y square equals to 25. Foot of the perpendicular drawn from foci of H upon any tangent. Okay, now the fourth option says the locus of foot of the perpendicular drawn from foci of H upon any tangent to H. Okay, what is this? This is just the definition of your auxiliary circle. So this is just the definition of your auxiliary circle. And what is the equation of the auxiliary circle? That is simply x square plus y square is equals to a square. So therefore this is simply x square plus y square is equals to 25. So therefore option D is also correct. Only third option is incorrect. All right. So yeah, this is a previous year JEE question. So you should quickly, like whenever you see these kind of questions coming up in your exams, you should quickly recognize them and then solve it on the fly. All right. So now let us proceed to the next question. So here we have an ellipse. So E is given as x square upon a square plus y square upon b square is equal to 1, and it is also given that a is greater than b. So therefore this is a horizontal ellipse, and it is given that E1 is the eccentricity of the ellipse. So E1 square will be 1 minus b square upon a square. All right. So this is your eccentricity of the ellipse. Now let a hyperbola is having its vertices at the extremities of the minor axis of the ellipse. So your minor axis of the ellipse will be along the y-axis. All right, and they are saying the extremities of the hyperbola are at the endpoints of the minor axis. So there is one extremity at 0 comma b and one at 0 comma minus b. Therefore you can write the equation as y square by b square minus x square, let us say it is p square, is equal to 1. Let us say this is the equation of the hyperbola. All right, so this is a vertical hyperbola. So the equation will look something like this. You got b here because the extremities are at b comma minus b, and we don't know what this is. So let us say that is p. Now what we can do, there is also one more information given in the question. The information is the length of the major axis of the ellipse. The length of the major axis of the ellipse is 2a is equals to the distance between the foci of the hyperbola. So the distance between the foci of the hyperbola will be 2b e2. There will be one foci here, one foci here. So the distance will be 2b e2. Therefore, A upon B will be your E2. Alright. Now, and also, what else can we deduce from this? What else can we write from this? We know E2 and we know E1 as well. Now, what we can do? What else we can do? So they're asking us the relationship between E1 and E2. That's all. So this is E1. So E1 square is equals to 1 minus B square upon A square. So this is equals to E1 square equals to 1 minus B upon A from here can be written as 1 by E2 square. So therefore, so that will be E1 square is equals to E2 square minus 1 upon E2 square. So E1 square E2 square is equals to E2 square minus 1. E2 square multiplied by E1 square minus 1 is equals to minus 1. So therefore this is simply E2 square into 1 minus E1 square is equal to 1. E2 square multiplied by 1 minus E1 square is equal to 1. So option B is correct. Alright. So this option will be wrong, this will be wrong, and even E2 is equals to 1, so that also will be wrong. So this is basically a single correct answer question. Alright. Now let us proceed to the next question. So you have a hyperbola given x square upon a square minus y square upon b square is equals to 1. A, B are greater than 0, whose center is C. So C will be your 0, 0, and one of the foci F1 on the positive x-axis. So F1 is simply AE, 0. And foot of the perpendicular from F1 upon the line BX minus AY equal to 0 is P, such that the triangle, okay. So you have F1 here. F1 is AE, 0, and you have a line here BX minus AY is equal to 0, and foot of the perpendicular is P. So this is P. So this is perpendicular, such that the triangle CF1P. So if you have the foci here, all right, then so your hyperbola will look like something like this. So this will be a center, and this line BX minus AY will be passing through this particular line. So foot of the perpendicular will be somewhere here. So your origin center C will be somewhere here. All right. So on this line. So what is given? CF1P. So this is F1. This is F1. So such that CF1P is an isosceles right angle triangle. So this is isosceles right angle triangle. So these this length and this length are equal, whose area is 8 square units. So half multiplied by F1P multiplied by CP is equal to 8. This is also given. So F1P multiplied by CP is equal to 16. We know F1P and CP are equal. So therefore F1P is equal to CP is equal to 4. Alright, so this length is 4 and this length is also 4. So therefore this length will be 4 root 2. But what is this particular length? So this is simply AE. So AE is 4 root 2. So this is what we got. Alright. Now what are they asking? They are asking us to find out the length of latus rectum of H and the eccentricity of H, distance between the directrices of H. Okay, they are asking us to find out all those things. Alright, that can be done. So BX minus AY is equal to 0. If you carefully observe, that is the asymptote of this hyperbola. Alright, so Y is equals to BX upon A. So this is the asymptote of the hyperbola. This is the equation of the asymptote. So you have an asymptote something like this, so which never touches this hyperbola, and you are drawing a perpendicular onto that particular asymptote, something like this. So this is your F1, this is your P, and this is your center. All right. Now you have to find out this angle. Let us say this angle is theta. So this angle is angle F1CP. So F1CP is theta. So therefore this is theta. But from this triangle we know theta is equal to 45 degrees. Alright. If theta is equal to 45 degrees, tan theta is equal to 1. So tan theta is the slope of the line. But what is the slope? Slope is b by a. So b by a is equal to 1. This implies a is equal to b. Alright. So we got a is equal to b, and we also know a is equal to 4 root 2. So let us find out the eccentricity of first. So eccentricity is square root of 1 plus b square upon a square. So that is simply, since b and a are equal, so we will get root 2. So eccentricity is root 2. Now moving ahead, okay, we got eccentricity is equal to root 2. So if you substitute that here, you will get a is equal to 4. Since a is equal to 4, b is also equal to 4. Now the length of lattice rectum is simply 2b square upon a. So that is 2 multiplied by 16 by 4. 4 ones, 4 fours. So therefore that is 8. So therefore the length of lattice rectum is 8. This is also correct. The distance between the directrices of H. The distance between the directrices of H. So that is simply a by e plus a by a. 2a by e. Alright. So that is simply 2. We know a is equal to 4 divided by e is root 2. So root 2 once, root 2 times. So this is 4 root 2. The distance between the directrices is simply 4 root 2. Next, the product of perpendiculars drawn from any point H to its asymptotes. So asymptotes are also the tangents. Okay. Let us say this is one asymptote. Okay. So you have this foci and this foci. This perpendicular length multiplied by this perpendicular length. That's what they are asking. So since asymptote is also a tangent, if you draw two perpendiculars from the foci to a particular tangent of the hyperbola, and let us say this length is alpha and this length is beta, then alpha beta will be your b square. Alright, this is a property. Try to prove it. If you don't know the proof, let me know in the comment section. I'll make a video. So that will be simply b square. So that should be simply 16. So this particular option is wrong. Alright. So the correct answers are A, B and C. So let us proceed to the next question. So this is your next question. Looks like this is also previous year JEE question. So we'll solve this. Let us go ahead and solve this. P be the point in the first quadrant. So you have a hyperbola given, a greater than b is given, a greater than 1 is given. So your hyperbola will look something like this. P be the point on it in the first quadrant. So you have point P here and a tangent at P. So you're drawing a tangent at P. So this is the tangent. So this tangent passes through 1, 0. And the normal at P cuts off equal intercepts. So this is your normal. So normal cuts off equal intercepts. Okay. So let us worry about the tangent first. What is the tangent equation for the hyperbola? X secant theta by A minus y tan theta by B is equal to 1. So this passes through 1, 0. So secant theta is equal to A. So this is what it gives us. Now, what is the slope of the tangent? Slope of the tangent will be minus secant theta by A divided by minus tan theta by B. So this is B by minus tan theta. This and this will get cancelled. So this is simply B secant theta by A tan theta. This is the slope of the tangent. Now what will be the slope of the normal? Slope of the normal will be simply minus A tan theta upon B secant theta. So let us say it is given that the normal cuts equal intercepts on coordinate axis. So then we can write x by p plus y by p is equal to 1 as the normal equation. So this is simply x plus y is equal to p. From here you get slope of normal is equal to minus 1. So these two quantities are equal. Therefore A tan theta is equal to B secant theta. Alright. So therefore this is simply A sin theta is equal to B. So we have these two things. So this is one thing that we got, and this is the second thing that we got. So sine theta is equal to B upon A from here. Alright. And we got secant theta is equal to A. So from here we got sine theta is equal to B by A. So we know eccentricity is 1 plus B square by A square for hyperbola. So this is simply 1 plus, since B by A is sine theta, this is simply 1 plus sine square theta. So E is simply square root of 1 plus sine square theta. We know sine theta, the minimum value of E will be when sine theta equal to 0. So that is 1. But sine theta cannot be 0 because they clearly told that the point P lies in the first quadrant. Alright. And this will be maximum when sine theta equal to 1. So the E will be root 2. Also, sine theta can never become 90 degrees. Alright. That is because if theta has to become 90 degrees, then the point approaches to infinity. Alright. So this point P is A secant theta, comma B tan theta. When theta is 90 degrees, this will go to infinite, and so this also will go to infinite. So therefore theta will never become pi by 2, but it will tend to pi by 2. So therefore 1 less than, it will not be less than or equal to, so it will simply be 1 less than E less than root 2. So this is the condition on eccentricity. So the first option is correct. Now we have to find out the area of the triangle delta. So this is the area of the triangle that we have to find out. Alright. So now this point is A secant theta, comma B tan theta. Now let us find out what this point is. Okay, since it is given that this cuts off equal intercepts on the coordinate axis, so there will be y-axis here. Alright, something y-axis like this, it will cut here. So this length and this length are equal. So this angle is 45 degrees and this is 90. This is also 45. Alright, so this is 45, this is 45. These two lengths are equal. This is what we got. Now, if this is 45 and this angle is 90 degrees, since one is tangent and the other is normal, so this also will be 45. Alright. 4. This is a right angle isosceles triangle. So this is your P. This point is 1, 0, and this is where it intersects. So if this is, let's say, A, so your area of the triangle will be simply half AP square. Half AP, this is also AP, half base into height. So half AP square. So your A is 1, 0. Your P is A secant theta, comma B tan theta. Alright. So this is P, this is A, and half AP square is the area. Since the area is in terms of A and B, we have to eliminate this particular theta. Alright. So we already got secant theta is equal to A. So therefore this particular point is A square. And tan theta, we have to find out tan theta. We know sin theta. Sin theta is equal to B by A. From here we know cos theta. Cos theta is 1 by A. So tan theta is equal to B. So therefore this point is B square. So this is B square. So now the area is half into the distance between these 2 points whole square. So that is simply A square minus 1 whole square plus B square whole square. Alright. So this will be this particular thing. Right. Now we know A is equal to secant theta. So A square minus 1 is secant square theta minus 1. That is simply tan square theta. Alright. So this is simply tan power 4 theta plus B square whole square. So that is B power 4. Alright. So we know sin theta equal to B by A. All right, sin theta equal to b by a. From here cos theta equal to b by a. So then from these two we know, so cos theta equal to 1 by a, sorry, from here cos theta equal to 1 by a. So using these two we will get tan theta is equal to b. So this will also become tan power 4 theta. So this is simply half into 2 tan power 4 theta. This and this will get cancelled. So this is simply tan to the power 4 theta. But tan theta is equal to b. Tan power 4 theta will be b to the power 4. So therefore your area of the triangle is simply b to the power 4. Alright, I hope I am clear. So now let us proceed to the next question. A rectangle ABCD has area 50 square units. An ellipse with area 50 pi square units passes through A and C. Okay. First let us draw the ellipse. This is the ellipse. So the area of the ellipse is pi AB. So this is given as 50 pi. So this and this gets cancelled. So your AB is simply 50. All right. This is what we have. Now rectangle ABCD. This is one foci of the ellipse. This is another foci of the ellipse. So here you have B. Here you have D of the rectangle. So something like this. So here you have A, here you have C. AC passed through the ellipse, BD passed through the foci. Alright, so this is what is given. And the area of the rectangle is 50 square units. So let us say this is P, this is Q. So BD, we know PQ is equal to 50. PQ is equal to 50. And we know BD is equal to square root of P square plus Q square. We also know BD is equals to 2AE. 2AE is square root of P square plus Q square. Alright. So now this angle is 90 degrees and this angle is 90 degrees. We also know P plus Q is equal to 2A. Alright, we know P plus Q is equal to 2A. So squaring on both sides, P square plus Q square plus 2PQ is equal to 4A square. So P square plus Q square is, so this is 100, alright, this is 100 plus P square plus Q square from here can be written as 4A square E square is equal to 4A square. So taking 4 out, so A square E square plus 25 is equal to A square. 25 is equal to A square into 1 minus E square. Alright, so this is an ellipse. So 1 minus E square is B square upon A square. So this is simply B square upon A square. So this and this will get cancelled. So your B is equal to 5. Alright, so from this you get A is equal to 10. Alright, so your eccentricity E will be 1 minus B square, 25 by 100. So this is 1 upon 4. So this is 3 upon 4. This is E square. So your E will be root 3 by 2. So 2 times A, your A is 10, your E is root 3 by 2 is equals to root of P square plus Q square. So this and this gets cancelled. 10 root 3 is equal to root P square plus Q square. So P square plus Q square is equals to 300. Alright, P square plus Q square is equal to 300. Now we have to find out the perimeter of the rectangle. Alright, so what is the perimeter of the rectangle? 2 times of P plus Q. So 2 times of P plus Q is 2A. So this is 4A. You know A is equal to 10. So 4A is equal to 40. So option 1 is correct. the length of the sides of the rectangle. So we have to find out both P and Q. Alright. So from here we have P plus Q is equal to 20. P plus Q is equal to 20. And we also have P square plus Q square is equal to 300. So we have these two. And the length of the major and minor axis of the ellipse. Major axis is 2a, minor axis is 2b. Major axis will be 20 since a is 10 and b is 5. So minor axis will be 10. So this is also correct. So perimeter of the rectangle is 80 units. So this is correct. This is wrong. Now you have P plus Q and you have B square plus Q square. Also somewhere I remember we found out PQ also. Yeah, PQ is 50. So P plus Q is 20. PQ is 50. Alright. Therefore P plus Q can be written as 50 by P is equal to 20. P square plus 50 is equal to 20P. P square minus 20P plus 50 equal to 0. P is minus B plus or minus square root of B square minus 4AC upon 2A. So this is 20 plus or minus, this is simply root 200. So that is simply 10 root 2 by 2. So that is simply 10 plus or minus 5 root 2. So one side is 10 plus 5 root 2 and the other side is 10 minus 5 root 2. So that is the answer A, B and C. So now we come to the final question. Common tangents of the circle and the parabola intersect the negative y-axis at T. Alright. So you have a circle, something like this. Alright. You have a circle, something like this. And you have a parabola, something like this. Now you are drawing common tangents to both circle and parabola. Since there is symmetry, they intersect on the negative y-axis. That is also given in the question. And this point is T. Alright. An ellipse whose center is at origin. So center is origin and semi-major axis is OT. OT is the semi-major axis. This is O and OT is the semi-major axis. The lengths of semi-minor axis are 1. So these are the ends of the semi-minor axis. So there is an ellipse something like this and OT is the semi-major axis. Alright, is drawn. Then which of the following statements are true? So this is the construction. So you have a parabola, you have a circle and then you have an ellipse here. Alright, so now you have to find out the area of the ellipse. So you know this part. So you have to find out this length to find out the area. So it is just that you have to find out OT. Equation of the common tangent of circle and parabola. So there will be two equations. So you have to find the common tangent and one of these should be here. Eccentricity of the ellipse. Once you find A and B, it is not difficult to find the eccentricity of the ellipse. And also once you find A and B, latus rectum is simply 2B square upon A. And the point of intersection of perpendicular tangents of the ellipse. So this is simply x square plus y square is equals to a square plus b square. Alright. So this is what you have to do. Take this as a homework. Take this question as a homework and let me know what are the answers to this question in the comment section. So with that we come to the end of this video. If you like the content that I'm making, share the videos with your friends, subscribe the channel, and in particular if you like today's session, do not forget to like this video. And I also have lot of fantastic videos on the channel. Make sure you check them out. And for the upcoming JEE Mains and JEE Advanced, I'm doing lot of videos where I solve questions from the question papers of different coaching institutes. Make sure you check out the videos, and I have attached a link to my Telegram channel in the description. Make sure you join the channel, and I'll meet you in the next video. Till then, take care. Bye bye.